In this tutorial, we're going to be solving an exercise about vectors. Two triangles have vertices A, B, C, and D, E, F. The coordinates of the vertices are, as you can see here, we have for each point on this triangle the coordinates. So we are going to leave these coordinates for the exercises, and we're going to also get to draw them later. We're going to solve part A at first. Part A of this question says, compare the vectors AB and DE. Now, to compare these vectors, the first thing that you're going to have to do is to find the x and the y. So we say x of AB is equal to the x of the second point, which is B, minus the x of the initial point, which is A. And you can find them here. X of B 3, x of A 0. Answer is 3. Now we're going to do the same thing for the y. We say that y of AB is equal to y of B minus the y of A. And that would be 2 minus the y of A, which is 0. And that would be 2. And so they have the components of 3 and 2. So that would be for AB. Now let's do the same exact thing for DE. X of DE is equal to the x of E minus the x of D, which is 7 minus 1, and that would be equal to 6. Now do the same thing for the y. Y of DE is equal to the y of E minus the y of D, and that would be 5 minus 1, which is equal to 4. So DE has the coordinates of 6 and 4. And so that would be for the first one. Now I'm going to do the same thing for AC and DF. For the vector AC, let's start with the x of AC. That would be x of C minus the x of A, which is 2 minus 0, which will have a final answer of 2. Now do the same thing for the y. Y of AC is equal to 5, which is the y of C, minus 0, which is the y of A, and that would be 5. So it's going to have the coordinates of 2 and 5. Now for DF, if you do the same exact calculation, you're going to have 4 and 10. So let's go ahead and compare. If you take a closer look at AB and DE, you can notice that DE is the double of AB. It has 3 and 2, but if you multiply them by 2, you're going to have 6 and 4, which are the exact same coordinates of vector DE. So you can say that vector DE is equal to 2 times the vector of AB. And so here, this is one conclusion that you can come up with. You can know that DE is double. Same goes for AC and DF. If you multiply AC by 2, you will get DF. So DF vector is equal to 2AC vector. Now, this is something that you can point a conclusion out from. And that is through solving part B, of course. What does this tell you about the triangles ABC and DEF? Now, the first thing that I'm going to do is to plot the points ABC, DE, and F on the graph on the right side of the screen. So A is at the origin, B is at 3, 2, C is above, D is at 1, 1, E is up there, and finally F at 5, 11. So connect AB and DE, connect AC and DF, and now for the final step to compare both triangles, connect BC and EF. So here we can take a closer look at these triangles. One thing that you can directly say is that the triangle is twice as much as bigger as triangle ABC. But this is not enough. You cannot just say that it is similar to each other and they are double the size. Of course they are similar, but you need to prove that. And that is through what we have done in the initial exercise in part A. We have shown that vector DE is equal to 2 times vector AB. And also vector DF is equal to 2 times vector AC. So we say DE over AB is equal to DF over AC, which is equal to 2. And so this would basically mean that both triangles are similar, since they have two equal ratios of two different vectors. Again, DE and AB are double, DF and AC are double. So we have similar ratio. So ABC and DEF are similar triangles with ratio of similarity equal to 2.